Hello again. By now, we've covered a lot of ground in speech recognition. We've even transcribed an audio file using the Speech Recognition Library, and OpenAI's transformer-based whisper model. But within companies, audio data is often stored as multiple files, whether it's recorded phone calls, customer conversations, or interviews. As a data scientist, analyst, or audio professional, handling and transcribing multiple audio files simultaneously is not just a nice-to-have skill, it's essential. This ability is crucial when dealing with large datasets, allowing you to efficiently convert vast amounts of audio information into accessible text data. It opens the door to advanced techniques like sentiment analysis, training machine learning models, and transforming unstructured audio into structured text, simplifying the process of extracting insights and making data-driven decisions. Okay, let's move on and see how you can streamline this task. First, specify the path to the directory where all audio files are stored. You can download the necessary files from the Resources section in this lesson. We'll transcribe only 8 audio files for this demonstration to show you the technique. In real-world scenarios, however, you'll likely be working with many more recordings, tens or even hundreds at once. Our method is identical whether you have 8 or 800 files. In this lesson, we'll describe the overall approach which you can easily apply to larger datasets. Okay. Now, type the path to your directory and store it as a string in a variable named directory path. Doing so lets us quickly reference the directory location throughout our code without writing it each time. Useful, hey? This is the path to my folder, but feel free to adjust it to match your own. Next, we'll define a function to handle the transcription process for all the files in the directory. In a new cell, type def, then the name of the function, followed by the required parentheses, where we'll place the variable containing the path to the desired directory. Here, the transcribe directory whisper function takes the directory path variable as its argument, and it will look inside the specified directory. Then it will find all the WAV files and transcribe them individually. But to do this, we need to type a bit more code. We'll first create an empty list called transcriptions, which will store the transcription results for each audio file. Each entry in the list will be a dictionary storing the file name and its corresponding transcription. To achieve this, we'll use a for loop to iterate through all the files in the dictionary. We'll employ the list_dir function from the OS module to retrieve the names of all files in the directory. Inside the loop, we'll add a condition to process only WAV files. With the help of the ends_with function, this if statement will check if the file name ends with WAV. If it does, the code inside of the if block will be executed. If not, the file will be skipped. Okay, what's next? For each WAV file, we need to construct the full path to the file using os.path.join. As arguments to the function, we'll combine the directory path and the file name to create a complete path that points to the exact location of the audio file. Store the result in a separate variable called filesPath. Now, with the path in hand, we can transcribe the audio file using the whisper model. Type results, followed by an equal sign, then model.transcribe, and the file's path variable as an argument to the function. On the next line, we'll extract the actual transcribed text from the result using the text key, just like we did in our previous lesson. Save this text in a variable named transcription. Finally, we'll append the text and the file name to the transcriptions list. Each dictionary will contain the file name as the key and the transcription as its corresponding value. After the loop finishes processing all the files, the function will return the complete list of transcriptions. Great! To get the transcriptions for all the audio files, we can run the function in a separate cell and pass the directory's path as an argument. Let's display the transcriptions variable and wait for the result. Excellent. We can now see the name of each track alongside its corresponding transcription, and everything looks spot on. Great job! With this, we can conclude the lesson, but there's more to come. In the next one, we'll demonstrate how to store these transcriptions in a CSV file, making them ready for further analysis and experiments. Thanks for watching, and see you soon.